Hello, everyone. Okay. Right. So I hope that you managed to submit the assignment. All right. This is the assignment 2. That was DC electricity, and we were doing yes, right angle triangles. Now, the next 2 topics, which will be published this week, okay, they will publish, well, we'll definitely publish at least physics or math in the next 1 or 2 days. But the physics assignment is on motion. Okay, the physics assignment is on 1D motion. It's kinematics. Okay. Now, today the topic is going to be motion. Okay, let's have a look on. Let's have a look at a few problems. Okay. So. I see. That's fine. Okay, I'm going to share my screen. And yes. Perfect. And a few problems that we are going to talk about. Problem 1. A car travels at half the distance at 40 miles per hour, and it travels Iksha, yes, please submit it as soon as you can. It's yeah, unfortunately we just didn't have, I don't have the capacity to answer all the emails. I still have like 100 unanswered emails just because I can't manage to reply them quickly. So I will answer all of them. It just takes time. Okay, so apologies for that. Okay, a car travels a distance, half the distance at 40 miles per hour and half the distance at 60 miles per hour. What is the average speed? Can somebody give me an answer? Okay. And type 1 if you realize that this is a trap. Okay. Right, so the answer is clearly not 50. So let's well, no, that's nothing to do with it. You can still calculate the average speed. So let's unwrap this question one by one. So suppose we didn't notice that this is a trap, and suppose the answer is 50 miles per hour. What would be if it's V1 and V2? What would the answer be? It would be an expression, right? What would the expression be? Somebody tell me. If we were to calculate the same way, like how did you calculate? Very good. V1 plus V2 divided by 2. This is the proposed formula for the speeds. Use an extreme case to test this equation. Okay, so in physics we often do extreme cases, and I think I've spoken about extreme cases a couple of weeks ago. So an extreme case in this situation would be, so extreme case travel from A to B, and let's say it is 1 kilometer, and you travel in this direction at 1 kilometer per hour, and the return journey you travel at 1,000 kilometers per hour. Okay. So imagine the distance is 1 kilometer. So how long does it take you to travel from A to B? Time from A to B. One hour. Time from, okay, so using this formula, your average V1 plus V2 divided by 2 should be 1 plus 1,000 divided by 2, which is approximately 500. So your average speed should be approximately 500 kilometers per hour, right? This is our initial idea. And then time from A to B is 1 hour. Time from B to A, Vishaka, a nice idea, but this has nothing to do with the difference between velocity and speed. So we don't care much about those. Doesn't matter. In this case, it doesn't matter whether we're talking about speed and velocity, but we're talking about speed. Okay. BA, the time would be 1,000th of an hour. 1,000th of an hour is about, yeah, so you might as well just say that it takes you 0 hours, which is approximately 0 hours, right? We are doing an extreme case, and I'm rounding 0.001 hours to 0 hours. Doesn't really make much of a difference, okay? So what do we have? Total time is 1 hour. Total distance is 2 kilometers. So what's the average speed? Two kilometers an hour, which is very far from the expected 500 kilometers an hour. Okay. So we were wrong. This formula is not valid. Not valid. Okay, let's try to figure out what went wrong. In questions like this, sorry, does everyone understand what I've just done? I've actually calculated the average speed, and the average speed is not even close to the average speed calculated by this formula, right? So this formula is not valid. Are there any questions? How do you get the time? Well, I divided the distance by, okay. Let me just write a few comments here, because this is an extreme case. In extreme case, travel A to B at 1 kilometer per hour, and travel B to A at 1,000 kilometers an hour. Traveling from A to B takes you 1 hour because it's 1 kilometer and you are traveling at 1 kilometer per second, or 1 kilometer per hour. This is for assignment 3. Yes, indeed. Assignment 3 is going to be on motion. And backwards, it takes you no time because you're traveling so fast. You travel 1 kilometer, you can't even. It's just it's less than 3 seconds. Assignment 3 is going to be set this week. Apologies, we're running at capacity. I think I'm working 15 hours a day at the moment. We're plowing through. We're plowing through and trying to release them as soon as possible. Okay. Now, average, and then I calculated the average speed, and the average speed turned out to be 2 kilometers an hour, so very far from the 500 kilometers an hour, which was predicted initially. Okay. So the formula doesn't work. The V1 plus V2 divided by 2 formula does not work. Oh, I could. I mean, B would just be the middle. It's just the distance is 2 kilometers. This is A, this is B, and then you're back to A. So you travel this distance at 1 kilometer per hour, and you travel this distance at 1,000 kilometers an hour. And this is 1 kilometer, and this is another kilometer. So yeah, it doesn't really make a difference. So what actually happens? What is the actual average speed? Well, to answer this question, let's take an easy distance. Assume total distance is 240 miles. I'm just choosing a convenient number that divides by 60 and by 40. That's all what I'm doing. Then first 120 miles at 40 miles an hour. The time, how long does it take for the first half? Miles. Thank you. Yes, 3 hours. And at 60 miles an hour. And the time is 2 hours. So the time is 5 hours. And the distance is 240. So average speed is 240 miles divided by 5 hours, which gives you 48 miles per hour. Okay, so not far from the 50, but not 50. So the answer is 48. So 50 is incorrect. The average speed is 48 miles per hour. Let's work out the formula if the general formula. The formula doesn't work at all. The formula never works. That's what I'm trying to say. It's the wrong formula. Let's find what is the actual formula. What is the actual formula? Okay, so what do we do? Let's say we have a distance. Let's say the distance is 2s. The distance is 2s. This is convenient because I can use s is the first half and s is another half. So the first half is an s and the second half is s. Okay. the first part V1 and the second half is V2. So what is the time for the first half? S divided by V1. Thank you very much. S divided by V1. Time for second half is T2 is S divided by V2. Total time is S divided by V1 plus S divided by V2. Total distance is 2S. Average speed, by definition, is the total distance divided by total time, which is S over V1 plus S over V2 divided by, that doesn't make any sense. Yeah, of course it doesn't. 2S divided by S over V1 plus S over V2. Okay. And in this case, I can say 2S. We find the common denominator here. It's V1, V2. And S, open bracket, V1 plus V2, which is 2S V1, V2 divided by S V1 plus V2. Bam, bam. And so the formula for the average speed is 2 V1 V2 divided by V1 plus V2. Okay, interesting. All right, let's say test for test. V1 is 40, V2 is 60. So average speed, V average is equal to 2 multiplied by 40 multiplied by 60 divided by 40 plus 60. 2 times 40 is 80 times 60 is 4,800 divided by 100. It gives you 48 miles per hour. It works. The formula works. Now, test the extreme case. Test 2. V1 is 1 and V2 is 1,000. Let's see if that works. And V average is equal to 2 times 1 times 1,000 divided by 1 plus 1,000. 2 times 1, that's 2,000. Divided by 1,001. Well, that's approximately 2 kilometers per hour. Works. Okay. So when we looked at the question initially, it says the car travels half the distance of 40 miles per hour and half the distance at 60. A lot of you immediately jumped to 50 because that's what I wanted you to do. Well, that's what I wanted you to do. Okay, so I tricked you a little bit here. The problem, and this one doesn't work. And we tested it with an extreme case. We saw that in the extreme case, it doesn't work. And then we devised a better formula, which is harder, of course, but it works. Now, why did the first formula not work? Can somebody, does somebody have an answer why the first formula didn't work? Yes, Iksha and Iksha, yes. So both of you are correct. They spend a different amount of time. If I said it travels half the time at 40 and half the time at 50, the answer would be 60. The answer would be 50. But because it says half the distance, it takes more time to travel the first half of the distance than it is to travel the second half. Therefore, you need to take that into account. Okay, this is why it doesn't work. Okay. How well do you understand the first question on a scale of 0 to 10, please? It's 9.9 recurring. 9.9 recurring is 10, by the way. It's exactly 10. Okay. So there's lots of stuff here that there's a lot of stuff to talk about, but please remember this formula because you will need this a lot. You don't really need this formula because this is a very specific formula which works at very specific times. But so yeah, generally you don't use it. We don't use it in physics. Problem 2. A runner is running at 3 meters per second. How far will she go in 2 seconds, 5 seconds, 10 minutes, and t seconds? Well, that's a very straightforward question. I mean, there's no this is not a trick question, unlike problem 1. So in 2 seconds, it will travel. She will travel 6 meters. In 5 seconds, she will travel 15 meters. In 10 minutes, she will travel 1,800 meters. Okay. And in t seconds, she will travel, somebody? 3t meters. Well done, 3t meters. What I'm trying to say that if we know the time, we can work out how far she traveled. Okay. Assuming we are within the time limits of the race, because we probably wouldn't be able to. You wouldn't be able to tell where how far she goes in 70 million seconds. Okay, because probably she won't be running at that time. But yeah, this is what I want you to focus on. At a speed of 3 meters per second, she will travel 3 times t. What if she's traveling at v meters a second? Like same thing, but at v meters a second, how far will she travel in 2 seconds? Well, in 2 seconds, she will travel v times 2. In 5 seconds, she will travel v times 5. In 10 minutes, she will travel v times 600, and in t seconds, she will travel vt, a distance of vt. We will see this a lot of this later today, but just keep that in mind. Does this make sense to everyone? Does this make sense to everyone? Is there anyone who doesn't understand what's going on? Okay, so hopefully I've warmed up your brain with the problem one. Hopefully, yeah, hope I didn't melt it. Okay, so a running track has a marks every meter. So you can imagine a running track which has a marks 1, 1, 2, 3, 4, 5, 6. So the runner starts at 230 meters. Okay. Where will she be after 2 seconds? Yes, the same runner. The same runner who's running at 3 meters a second. There's the same, the runner. She's not accelerating. No, she's constant speed. 236, yeah. 236. After 5 seconds, it would be 245 meters. After 10 minutes, 2030, yes, thank you, meters at the 2030 mark. And after t seconds, and that's the crucial part, t plus 230. Well done. 230 plus 3t. Right. Okay. So we're coming close to something that is called an equation of motion. What if it's the same runner at the x0 mark, and she's running at v, speed v starts at the x0 mark. So now the runner starts at the x0 mark. Where will she be after 2 seconds? X0 plus 2v. After 5 seconds, it's x0 plus 5v. After 10 minutes, it is x0 plus 600v. After t seconds, it's going to be x0 plus vt. Ooh, we've done something interesting. X0 plus vt. So this is the expression that tells you where she is at time t. This is the expression and this expression, we call it the current position. So x is the current position of the runner. So the runner is here at x. So x is equal to 230 plus 3t. But this is a function of time. So we to show that it is a function of time, we write it as like this. X of t is 230 plus 3t. So it's a function of time. So this is the function of time. Basically, if you know the time, you know x. So x of 2, for example, is 236. Yes, 236 meters. X of 5 is 245 meters, etc. So this thing, x equal x0 plus vt, or x of time is x0 plus vt, is known as the equation of motion. Equation of motion. It tells you where the object is at any given moment in time. And this is the purpose of mechanics. Mechanics is a study of motion, and the purpose of mechanics is to know where something is at any given moment in time. So very useful, for example, in astronomy. At any given time, you need to know where a planet is, or a satellite is, or a rocket is. It's really, really important stuff. If you're controlling trains, you need to know where the train is at any given moment in time. Of course, the speed can change. This is only for constant speed. Constant, I'd say, yes, speed. Even I'd say velocity, but only for constant speed. Right. So we're moving on to problem 4. So what is an equation of motion? An equation of motion is an equation that tells you the position at any given moment in time. Is a function x of t. Tells you the position at any given time. Gives you position x at time t. Okay, you might think why am I doing doing like really easy things and focusing so much on them? because sometimes it's not obvious. Yes, if you remember in the first assignment, you had the last question. Well, the last question on maths was an equation of motion of an object. So for a uniform motion, that means constant velocity. Well, we already know is x of t is equal to x0, the initial position, plus this velocity times time. That is the equation for uniform motion. And that means constant velocity. For uniformly accelerated motion, well, okay. For uniformly accelerated motion, it is uniformly accelerated motion. So what, like similar to this expression, I can write for uniformly accelerated motion, or uniformly accelerated motion. Let's say, so V U is the initial velocity, and V is final velocity. Acceleration is the final velocity minus the initial velocity divided by time. And from here, I can make V the subject. V is equal to U plus AT. And if you are observant, you will notice that this does look very much like an equation of motion. Like it looks very much like this one, because you can say that is V of t is equal to U plus acceleration multiplied by time. It gives you the velocity at any given moment in time. It's the velocity at any given time. Do you see how these two formulas look very much alike? Does anyone have any questions? Anyone have any questions? Because well, we're almost done, but I really want you to. Any questions? Okay. Do you understand how I got this equation, the second one, the second framed equation? On a scale of 0 to 10, please. Do you understand how I got this? Ooh, not many. What would the graph be for uniformed and accelerated motion? Well, a graph, depending on what you're trying to achieve. So that's a good point. Let's draw. Now, the first one, this is x, the position with respect to time, and this is time. So when time is 0, your position is x0, and then your position changes according to well, so your position in time with respect to time is x0 plus vt. Now, with uniformly accelerated motion, so this is uniform motion. This is uniformly accelerated motion. This is v of t. And this is t. You start with v0, initial velocity, sorry, not u, initial velocity u. And then it increases just the same way. Because the graph is the same, just different axes. V of t equals u plus at. Does that make sense? Now, if you want to draw the uniformly accelerated motion on this graph, it would look like a parabola, like this. And here, the uniform motion would look like a line like this. But let's not focus on that for now. So the graphs are the same, the axes are different, so and they mean different things. Now from here, when you're talking about uniformly accelerated motion, this is A, B. Now we can say that with the uniformly accelerated motion, the distance traveled is the average velocity multiplied by time. But the average velocity is v u plus v divided by 2 is the average velocity. It's v1 plus v2 divided by 2. So the initial velocity plus the final divided by 2. So you got the average velocity multiplied by time. And if you plug that in, u plus v, and we know that v is u plus at divided by 2 times t. So that is 2u plus at divided by 2 multiplied by t, which gives you ut plus 1/2 at squared. If you simplify this, at divided by 2 times t is 1/2 at squared, which looks very familiar. Well, it should look familiar. Plus 1/2 at squared. Now, what is S? Well, S is the displacement. And what is the displacement? Well, the displacement is the final position minus the initial position. This is displacement is x minus x0. So we can write x minus x0 equals ut plus 1/2 at squared. And now we can write x is equal to x0 plus ut plus 1/2 at squared. And of course, it's a function of time. So this is the uniform. Compare it to the uniform motion. Yeah, so this is the uniformly accelerated motion, and this is the uniform motion. Okay. So this is displacement at any given time. Not displacement. Why did I say displacement? Position. 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 Okay. So I hope that makes sense. I hope that makes sense. It's a position at any given time. So we'll get back to those. We'll get back to those. I just want to show you how to use the equation of motion. The equation of motion of an object is x equals 6 plus 3t and y equals 4t. Okay, find the equation of the line on along which it is moving. What is the speed? And find the distance traveled in the first 5 seconds. Okay, so let's have a look. We can draw a graph, but this is not a time graph. This is an XY graph. XY graph. So when t is 0, xy is 6, 0. Do you agree with that? Do you agree with this statement? Do you understand it? Yes or no? When t is 0, x is 6 and y is 0. Well, this should be straightforward. So 6 and 0, so 1, 2, 3, 4, 5, 6. So when t is 0, this is 6 and this is 0. When t is 1, this becomes 9 and 4. So 1, 2, 3, 1, 2, 3, 4. So after 1 second, you have moved to this position. After 2 seconds, t equals 2, this is going to be 12, and this is going to be 8. So 12 and 8. So this is your position at t equals 2 seconds. So it looks like you are moving along this line. So let's test t equals 3 seconds. The position 3, so that's going to be 15, comma 12. 15, so that's 15, 12. Okay, that's it. T equals 3 seconds. It does work. So that's 15. This is 12. So the first question is, find the equation of the line along which it is moving. So we need to find the equation of this line. Can somebody help me with this? It's a straight line. It has a gradient. It has a y-intercept. Four. 4. What do you mean by 4? Equation of a straight line. Equation of a straight line is y equals mx plus c. Y equals mx plus c. So to work out, you need the slope, the gradient, and you need the y-intercept, which is c. What is the gradient? Okay, let's work it out. The gradient is 4/3. Very good. So it's 4/3 x plus. What is the y-intercept? Not -2. -8. Yes, Dennis. Thank you. It's -8. -8. So this is the equation of motion. So let's see if it actually is that. So what I'm going to do is I'm going to make t the subject. So t is equal to y divided by 4. And I'm going to plug that into here. So x is equal to 6 plus 3 multiplied by y divided by 4. And this gives you x equals 6 plus 3/4 y. And we multiply this to make y, so we multiply this by 4/3. So 4/3 x equals 6 multiplied by 4/3 is 8 plus y. So then we have y equals 4/3 x minus 8. So it is true. So we obtained it in two different ways. We've drawn it and we've obtained the equation of the line. And then we have we did it algebraically. Okay, so cool. Now that's problem 5 for you. And problem 6. Problem 6. Oh, no, sorry. We haven't finished. Apologies. What is the speed? Well, how would you calculate the speed? So A, B, C. So A is moves along line y equals 4/3 x minus 8. Okay. There's a gradient. The speed. Okay. The gradient of a distance time graph is the speed, yes. But this is not a distance time graph, yes? Okay, the gradient of a distance time graph is the speed, but this is not a distance time graph. So what is the speed? Well, okay. When they first taught you about speed in school, which hopefully happened 5 or 6 years ago, like in year 5, what did they tell you? How do you calculate speed? What do they say? To calculate the speed, you need to do what? Distance divided by time, of course. You need the distance divided by time. So, well, we can assume that the speed is the same. It doesn't change because it looks like through in equal intervals of time, we travel the same distance. So we know the time. Can we work out the distance? Well, let's say because we can take the first 1 second or the first 2 seconds. It doesn't really matter. So let's take the first 1 second. How far do we travel in the first 1 second? What is the distance between this point and this point? These are points on a plane. 6, 9, 4. Anyone? What's the distance between these 2 points? This is an XY plane. This is in meters, and this is in meters. We are on the plane. It's not 3. Okay. Let's say we have point A, six, and point B, is 9, 4, 0. Okay, so here's point A and here's point B. So when the object starts at 0 seconds, it is point A. And this is 5. Ooh, very good. Very good. Dennis and Luke, you've worked it out. You actually worked it out. So 9 and 4. And the distance segment. The distance is how do I measure the length? Okay, I can't find the length. Oh, distance or length. Yeah, it's 5 meters. So it travels 5 meters, as you can see, from 6 to. So yeah, that is 5 meters. And then it travels another 5 meters. 5 meters. 5 meters. So the speed is 5 meters per second. Speed is 5 meters per second. Oh, because Pythagoras theorem. This is 3 and this is 4. This is 3, this is 4. 3 squared plus 4 squared equals 5 squared. Does that make sense? Yeah, because when you start moving, you are here. In 1 second, you are here. So how far did you travel? You traveled 5 meters. Yeah, so this is x and this is y. And actually, if we are really clever, we can do tricks. C is equal to 6, 4, or 0, 0. And then we can have 6 plus 3, 3a. And this is 4a. And we can change a. Look, and C moves. You can see C moving. So we can change that. Settings. Slider from 0 to 2 seconds. And look, if I click play, look what happens to point C. Settings, let's make it brighter. Color, green. Point size. Okay. I press play, and C moves from A to B and goes beyond B. Then it'll probably come back. Yes, it will probably come back. So as time goes by, you can see, so once again, so when t is 0, so A is time in this case, A is time. So when time is 1 second, 1 second, it passes B. After 2 seconds, it will be at a different point. Okay. Does that make sense? Do you see it now? Do you understand it better? And in 1 second, you can see it travels 5 meters. Okay. Any questions? Do you consider it cool? type cool if you think it's cool. Type I've seen better if if it's not cool. And of course you can. Okay, let's play some games with it a little bit more. So you can, of course, you can have an equation of motion in 3D. So I'm just going to pause this and go back, and rather than putting it, so I'm just going to remove these, and I'm just going to create a different type of motion. So rather than this, I'm going to put, let's start with from point 2 plus I don't want to give it away, but okay, I'm gonna give it away. 2 multiplied by sine open bracket a divided by 5, and then this is going to be 2 multiplied by sine a divided by 5, and this is going to be a multiplied by 2. Let's see what happens now. Oh, 2 cos. That makes more sense. Okay, so looking at x and y, and it's moving like this. Can't really see. Slider max. Oh, that's my mistake. Okay, a divided by 2. No, 4a. 5a divided by 2. Not even 5. 7a divided by 2. Okay, sorry. 7a divided by 2, and that should be better. Okay, so looking from the top, here we go. It's moving in a circle. If you look from the top. If you look from the side, it's moving in a spiral. So yeah, you can duplicate. Okay, so that's that is I just played around with it a little bit. Okay, problem 6. Describe the motion of the object. X is 4 multiplied by sine 3t, and y is 4 multiplied by sine by cos 3t. Describe the motion of the object. Well, let's see. I think it's worth taking assignment 3. Is it one a month? Yes. The next assignment is, I think it's 17th of December. And yeah, so when t is 0, we just do x of 0 is 0. So that's 0. And y is 4 times cos 3t. It's going to be 4, because cos 0 is 1. 4 times 1 is 1. So 0, 4. So 1, 2, 3, 4. So this is when t is 0, x and y. Let's take t is 10. If we take t is 10, this is going to be 4 sine 30 and 4 cos 30, which is approximately 4 multiplied by a half and 4 multiplied by square root of 3 over 2. And that will give you 1/2, which is 1/2 on the x. So 2 on the x, sorry. And it's going to be approximately like this. And then when you take t equals 20, that's going to be 4 sine 60, 4 cos 60. It's going to be square root of is going to be 2 square root of 3, comma 2. This is going to be here, 2 square root of 3, comma 2, which is this and this. And when you follow it up, you will see that it is going like this. And you'll see that the object is moving in a uniform, this is called a uniform circular motion, moving in a circle. So t is 0, t is 10, t is 20, t is 30, t is 40, t is 50, etc. Let's have a look. I have prepared this for you. Oh. Okay, here it is. So we have an object with coordinates 4 sine. I've scaled it down because this calculator does radians, and 1 radian is 57 degrees. So that's what I did here. I just divided by 57 just to get degrees instead of radians. And let's have a look. We're going to play. And you can see that it is moving in circles. Okay. Assignment 3 is due, I believe, the 17th of December. 17th of December. Yes, that is correct. Right. So this is the equation of motion. So this is circular motion, and yeah, it's just another type of motion. Let's actually show in a different way that it is a circle. So we have x is equal to 4 sine 3t, and y equals 4 cos 3t. Let's have a look. So what we can do is we can square both equations. Square both sides. We get x squared equals 16 multiplied by sine squared 3t. And y squared is 16 multiplied by cos squared 3t. Now, if you add the two equations together, if you add the two equations, we get x squared plus y squared equals 16 sine squared 3t plus 16 cos squared 3t. So x squared plus y squared is 16, open bracket, sine squared 3t plus cos squared 3t. What is sine squared plus cos squared? Sine squared 3t plus cos squared 3t. It is 1. So it goes x squared plus y squared equals 16. This is an equation of a circle. Are you familiar with the equation of a circle? Radius, yes, the equation of a circle of radius 4, indeed. Is that a yes or a no? Are you familiar? Are you familiar with the equation of a circle? Yes or no? Okay. Kind of. All right. So if you take, okay, so x squared plus y squared equals 16. It's a circle of radius 4. This is the equation of a circle. Circle of radius 4. So you can write this as 4 squared. So x squared plus y squared equals r squared, where r is the radius. So if you want radius 5, it's going to be like this. Radius 6, like this. Radius 2, like this. Radius 0. Ah, that's a single point. It's a single point, which just work. Can you do minus 2, minus 1 squared? Well, of course you can, because minus 1 squared is... this one doesn't work, of course. Yeah, so this is I love this equation. X squared plus y squared equals 1. This is the equation of a circle that we have. Yeah. Well, minus 1 squared is 1, so it doesn't make any difference. Okay. Right. Yeah. So that's so the takeaway from this session is that an equation of motion describes the position of the object at any given time. And finally, what I want to do is to derive the Suvat equations. You might have done this before, you might never done this before, you might not know what Suvat equations are. There are 4 of them. In GCSE, you have 2. You have acceleration is v minus u divided by t. That's the one that you have in GCSE. And the second one is v squared equals u squared plus 2as. These are in GCSE. SE. And then you have 2 more. S equals ut plus 1/2 at squared. This is A level. And S equals u plus v divided by 2 times t. This is also A level. So there are 4 Suvat equations. What are Suvat? S is displacement. U is the initial velocity. V is final velocity. A is acceleration. And t is time. So Suvat equations are the equations, the 4 equations that connect S, U, V, A, and T. So these are the 4 Suvat equations. 4 Suvat equations. Okay, so let's start with the first equation. The first equation is kind of obvious. So acceleration is acceleration is the final velocity minus the initial velocity divided by time. So we can express this as v equals u plus at. We've already done this. And let's draw a graph. Okay, so this is v and this is time. So this velocity versus time. So when time is 0, velocity is u. It's the initial velocity. And then as time goes by, the velocity increases. So the velocity is u plus at. After some time, let's take this time to be t. So this is 0. The distance that you have traveled, and the final velocity is, of course, v. Okay. Final velocity is v. Distance traveled, your displacement, is the area under the graph. Displacement is equal to the area under the graph. Okay, so this area is your distance or displacement. If you're moving in a straight line, it is displacement. So area is equal to displacement. And this shape is a trapezium. And if you know the equation of the trapezium, its base, and this base is u, and it's the second base, which is v, and this is t. This is time. So it's a trapezium, and the area of the trapezium is 1/2 a plus b times h. So your displacement is equal to the area of the trapezium. So it's 1/2 multiplied by u plus v, is base plus base, times t, which can be written as u plus v divided by 2 multiplied by t. So S is u plus v divided by 2 multiplied by t. And this is the fourth equation. We've just derived it. It just comes from the area under the graph. Now we substitute v equals u plus at, and we get S is equal to u plus at divided by 2 multiplied by t. So it's 2u plus at divided by 2 multiplied by t, which is u plus 1/2 at multiplied by t. And this gives us S is equal to ut plus 1/2 at squared. This is where we get this the second. Is it the second? Is it the third? This is where we get the third Suvat equation. And finally, the second Suvat equation. Well, we make t the subject. So from here, we can make t the subject. So t is v minus u divided by a. and we sub that in to this equation. Substitute T equals V minus U divided by A into S equals U plus V divided by 2T. And what do we get? We get S is equal to U plus V divided by 2 multiplied by V minus U divided by A. We can simplify this, and it becomes 2A, and this is a difference of two squares. So V minus U times V plus U, which is V squared minus U squared. So I multiply everything by 2as is equal to V squared minus U squared. And finally, I get V squared is equal to U squared plus 2as. I would urge you to practice deriving these formulas. Finally, let's do a problem. We have just enough time. Just showing you how to use Suvat. Use Suvat. I should have started with this actually, because that's going to be less confusing if you start with this. So question one. Question one. A particle is moving in a straight line, so 1, with a constant acceleration. It passes a point with speed 3 and late passes point B where AB is. Find the speed of the particle as it passes through B. So you write down Suvat. So displacement is 8 meters. We traveled 8 meters. The initial velocity is 3 meters a second, 3 meters per second. The final velocity, we don't know, and that's what we are looking for. Acceleration is 2.5 meters per second squared. And time is not given, and we don't need time. Looking at the 4 Suvat equations, we notice that in the first Suvat equation, there's no S. In the second Suvat equation, there's no T. In the third Suvat equation, there's no V. In the last Suvat equation, there's no A, no acceleration. So we need the equation that does not contain T, because we don't need T. We need equation with no T. So we have V squared equals U squared plus 2as. So V squared is equal to U, which is 3 squared plus 2 multiplied by 2.5 multiplied by S, which is 8. So V squared is equal to 9. 5 times 8, that's plus 40. That's 49. So V is equal to plus or minus square root of 49, which is plus or minus 7 meters per second. And because the initial velocity is 8, I would say, so it's whoa, that doesn't make any sense. oh, we're talking about, sorry, we're talking about this one. Straight line, it passes point A with speed 3 and later passes point B, So yeah, you have to assume that it is +7. +7, because the -7 doesn't make any sense because it's accelerating. It's traveling at 3 meters a second and it's accelerating, so it can't get to -7. That's what I'm trying to say. So this is how you use SUVAT. You write them out, you decide which equation you are using, and then you just solve for the unknown value. So I'm just going to do another one really quickly. So 2 SUVAT. Let's check your understanding. What is S in the second question? $60. Well done. What is U? $8. Yes. Velocity, the final velocity. It looks like we don't know. We don't know, and we don't actually need it because we are looking for the acceleration. So we don't need velocity. Acceleration is the thing that we're looking for. Yeah, the acceleration is the thing that we're looking for. And T is 6. T is 6. Okay, so which equation do we need? The one that does not contain A. We need equation with no, with no V, sorry. So S is equal to ut plus 1/2 at squared. So 60 equals 8 multiplied by 6 plus 1/2 multiplied by A multiplied by 6 squared, 36, 18. So we have 60 equals 48 plus 18A. 18A equals 12. A is equal to 0.67 seconds. Okay. So I'll leave you here. We will publish the assignment in, we'll try to do it in the next 2 days. Sorry for the delay. I'll see you all next week. Welcome.